In this video, I'm going to show you the last two examples for the fundamental theorem of calculus and definite integrals, and also the best part, how to use a graphing calculator to check your answers to see if you got them right. So, on this problem, we need to go through and we need to do an algebraic rewrite before we're ready to find the antiderivative. So what we've been doing in class is we've been taking the x squared and bringing it up to the top. So you can think of this as being the antiderivative from -1 to 4 of the numerator, 3x to the fourth minus x squared plus 4 times x to the -2. Don't forget to write the dx in there. Sorry, I ran out of space, but make sure you write the dx. Integral sign being written, dx needs to be at the end. Alright, and then we're going to distribute in the x to the -2. So now we have the antiderivative from -1 to 4 of 3x squared minus 1 plus 4x to the -2. Okay? Be careful with that x squared times x to the -2. That's x to the 0, which is 1. It does not disappear altogether. So now to go through and take care of this, we're going to find the antiderivative using the power rule. So now we're going to have the antiderivative of 3x squared is 3x cubed over 3, or just plain old x cubed. The antiderivative of -1 is -x. And then the last one I have plus 4x to the -1 divided by -1. And we're evaluating from -1 to 4. Okay, so I'm just going to clean up what that last term looks like and write it so it's a little bit easier to work with. So what we really have here is we have x cubed minus x plus 4 over -1 is minus 4 over x, and we're evaluating this from -1 to 4. And now we're going to go through and plug in 4 first and plug in -1 second. So if we go through and take care of that, I'm going to have 4 cubed is 64 minus 4 over 4 is 1. So that's plugging in x equals 4 minus, now plug in -1. -1 cubed is -1 minus -1 will become plus 1, and then minus 4 over -1 is plus 4. So the two individual numbers here, the first number looks like it's 59, minus the second number is 4, so the final answer here is 55. Okay? Alright, so that should be a relatively easy problem for you to do. Again, it just requires that you do the rewriting process first before you start doing the power rule to find the antiderivative. Okay, last example, problem 6. All right, so we have to find the antiderivative of the square root of x plus 5. But here's the thing I want to point out on this one. Look at the bounds. It's saying we're going from 9 to 4. But we know intervals always have to go from least to greatest. So technically what we're supposed to do is go through and swap the order of the bounds. But in order to do that, I would have to multiply the whole thing by a negative. Okay? So this is an optional thing to do. You don't necessarily have to do what I'm about to write. So this is the same thing as the negative antiderivative of from 4 to 9 of the same function, square root x plus 5. So if you find that your bounds are written in the wrong order, you can swap the order of the bounds, but that means you have to put a negative out in front. Okay? Now, we're going to pretend like we didn't do that for a minute, and we're just going to follow through with what was written over here and see what happens, and then we can kind of compare if we need to. Alright, so if I just go into finding the antiderivative, keep in mind this is really the antiderivative from 9 to 4 of x to the 1/2 plus 5. Oops. And then when we go through the antiderivative process there, we get x to the 3/2 divided by 3/2 is the same as times 2/3, and then we have plus 5x. And we're evaluating that from 9 to 4. All right, sorry, this is getting a little sloppy here. So because we're going to be plugging numbers in, it might be easier if we write this x to the 3/2 as a radical. So this is 2/3. This is a square root of x cubed. And then plus 5x. Here we go. So now if we go through and we plug in the 4 first, because it's the upper bound, even though we know they're in the wrong order, we're going to get this. 2/3 square root of 4 cubed is 64. All right, and then we have plus 5 times 4. I should have just written plus 20 there. I don't know why I didn't. And then minus 2/3 square root of, okay, 9 cubed is 729. But it would actually be easier to do the square root of 9 first. And the square root of 9 is 3, and then cube it. So this number, the square root of 9 cubed, is actually just 27. So I'm going to get rid of that radical. Write that this is times 27. And keep in mind, you are going to have a regular calculator at least so that you can go through and do your computation. So don't worry about something like that. You could actually just type in your calculator 9 to the 3/2 and it'll spit out 27 for you. Alright, so the square root of 64 is 8. 8 times 2/3 is 16/3. So we have 16/3 plus 20. 2/3 of 27 is 18, so minus 18, and then minus 45. So it looks to me like we're going to get a negative answer here. So if I do the integer part first, I'm going to get negative 43. So we have 16 over 3 minus 43. If we got a common denominator, we would have 16 over 3 minus 129 over 3. So final answer there, 16 minus 129 is negative 113. Negative 113 over 3. So the area under the curve here, or the net area under the curve, is negative 113 over 3, meaning there's more area below the x-axis than above. Except, picture what the graph looks like. We're thinking about the square root of x plus 5. So the square root of x is already above the x-axis, and we have shifted it upwards. So the area underneath is definitely above the x-axis, so how could it be negative? And again, it goes back to what's written here. It's because the bounds are written backwards that this process is evaluating it in the wrong order. So that's why the area came out negative. And the area is in fact negative because to make the bounds go in the proper order, we technically need to multiply the entire function by a negative. So that means we're really finding the area under the curve, negative square root of x minus 5. And that graph is completely contained underneath the x-axis, and that's why the answer is coming out to a negative. Okay? So you have to be kind of careful here because you're going to get a negative answer from a function, square root x plus 5, that looks like it should have a positive answer. So because the bounds are backwards, that means the function is really being multiplied by a negative to get the bounds in the proper order. That's why we ended up with a negative answer. Okay. So now for everyone's favorite part of this lesson, learning how to check your answer with a graph and calculator so that you'll know if you're doing it right or not. Okay. So I would advise you to pause the video, write this down, and once you have it written down, then follow along with the audio. Okay, so how to check your answer with a graph and calculator. Anything written with a box around it is a physical button that you're going to push on your calculator. Okay, so you press the math button, which is right near the green alpha key. And then you push the number 9. Next to number 9 it says FNInt, function integrate. Okay, or at least that's what I think it means. Right? And then you see FNInt in a set of parentheses open up on your screen. So it actually will look just like this down here after you press math 9. Then you type in the function or the integrand, the thing that you're trying to find the antiderivative of. Then you hit a comma. Okay, comma is a button. It's a black button. It is right above the number 7. Okay, so you type in the function, hit comma, and then you type in what your variable is, in this case x. So you're always going to press the x button, the xt theta n. All right, and that's to represent the dx at the end of the integral. Then you hit the comma again. You type in your lower bound, the a value, the smaller value, comma, and then your upper bound, the b value. All right, so those are your two bounds, lower bound and upper bound at the end. So if we take a look at the problem that we just did, example number 6, our function was the square root of x plus 5, and then we would press the comma. Okay, and I'm putting the parentheses there because your calculator is going to put the parentheses, and you need to remember to close the parentheses in the square root of x before putting in the plus 5. Okay, so close the parentheses there, and we have a comma after. Then we have an x for the variable of integration, the dx at the end of the integral sign. The lower bound for us was actually 9, and the upper bound was 4. And if you type that in and then hit enter, it'll think for a minute, and then it's going to spit out a decimal. To convert that decimal back to a fraction, you want to hit the math button again, and then enter, enter. Oops. Math, enter, enter. And that will convert it back to a fraction for you to give you that answer that we had of negative 113 over 3. Okay? If we had changed the bounds, like I had written in green at the beginning of the problem, then we would have written negative square root x and then minus 5, comma x, comma 4, comma 9. And again, we still would have gotten the proper answer of negative 113 over 3. Okay? So you can use this to check your answers, but whenever you're taking a test or quiz, you have to show all the work to get the credit. All right, I hope that this was clear.